Okay, so this is page 157. Now I won't necessarily be able to do this every time, but have a look at this. It's just a matter of time because I do have a workload. So this is just the introduction to the lesson. I'm not going through all the examples, but hopefully this will give you a good grounding if you watch it before tomorrow. So you're starting your linear equations unit. So the first thing you start is by looking at the slope of a line segment. Now, linear graphs are straight lines that can either rise to the right, the left, or be vertical or horizontal. So if we think about that, if we have them and they rise to the right, bingo. If they rise to the left, okay. If they're vertical, straight up and down, or if they're horizontal, they are flat. Okay, and we're going to talk about all four of those kinds of lines. So I'm just going to erase them right now. Now, linear graphs are straight lines. We've talked about that. So here's a linear graph. So basically what we're talking about when we're talking about linear graphs is that it's a straight line. That's the key, right? Straight lines. So they don't have any bends, they don't have any curves, they don't change direction. Now, this line represents a linear graph that can be written in the form y is equal to mx plus b. So this form of the line, y equals mx plus b, is called the slope y-intercept form. And we'll talk about why, I think. If we don't, I'm going to talk about it now. That m is our slope, and b is our y-intercept. So that's a form of the equation for the line that tells us a bit about the line. If you know the slope and you know the y-intercept, you can write the equation of the line, which is good. Now, when we look at our linear, remember, we have our graph here where it crosses the x-intercept, so where y equals 0 is our x-intercept, and where it crosses the y-intercept, or where x equals 0, is our y-intercept. Okay, so those are two key points on our line. And our slope that we're going to talk about today, most of today is all about slope, is telling us how steep that line is, how fast it goes up versus how much it goes over. So a slope is how steep a straight line is. The bigger the slope, so 1.25 versus 0.5, the steeper the line. So the closer it is getting to being vertical, okay? And that's just numerical value because you can have a positive and a negative slope. So we're just looking at the number part, not the positive and the negativeness. Now, you've done a previous unit. The slope in the previous unit, we talked about it in terms of the rate of change, right? And we talked about that in terms of rise over run. So rise being how much it goes up versus how much it goes over. Okay, so up and down versus over, left to right. Okay, so if I look at this line here, that's presented to me here, my run, it goes over by so many, and my rise goes up by so many. And we've just articulated that by finding 2 points on the lines. Now, in the previous unit, we were talking about rate of change, so we talked about the dependent variable and the independent variable. Well, those can be matched up with your dependent variable is your y values, and your independent values is your x values, okay? So there are 4 different kinds of slope, as I mentioned. There's a positive slope. So positive slope means if you're looking from left to right, it goes up. Okay, so we can see this is going up from left to right. A negative slope is if you're looking from left to right, it goes down. Okay, so this one is, here's my left, here's my right, it's going down from left to right. Okay, now we have 2 other kinds of slope that I talked about a bit at the beginning. We have our zero slope, and a zero slope happens when we have something that's horizontal. So this is a horizontal line, And that's because there is no increase in the rise. The rise is 0. The run is infinite, or it could be infinite. But 0 divided by anything equals 0. So 0, if you have a horizontal line, you're going to have a 0 slope. The other one is the undefined slope, and this is a vertical line. Now, a vertical line, it has no change in the run. The run is 0. Now try that on your calculator. Anything, doesn't matter if it's 300, doesn't matter if it's 10 for your rise, how many it's going up. But if you go 15 divided by 0, you're going to get an error or undefined. If you go 40 divided by 0, you're going to get an error or undefined. Because 0 can go into another number an infinite number of times. So that would be undefined. So it's really important for you to take some time, make sure you understand the 4 different types of slope, okay? And some people get confused about positive and negative. Always think looking from left to right, okay? I'm reading the page from left to right. And then that'll help you with the going up or down. Now, when we're given a graph on a coordinate plane, we can find the slope of the line segment simply by picking 2 points on the line and then counting the rise and run. You always want to write your slope in reduced form. So, this first one, dun dun dun, we have a positive slope. We're not going to actually evaluate that one, it's going up. And the second one, we have a negative. So double check that to make sure you have your signs correct. So let's look at this first one. I've got 2 points on the line. And what I like to do is I actually like to think about it in terms of drawing kind of a little square underneath it. You don't have to draw it in, and it helps you for counting. So our slope, it's rise over run, right? Well, our rise, it goes up 1, 2, 3, 4, 5, 6. So my rise equals 6, and my run equals, it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I look at this, I can put this in lowest terms. 6 over 10. I can divide both of those by 2, and I'll get 3 over 5. So my slope would be 3 over 5. And then it's also asking for me x-intercept. X-intercept is where it crosses the x-axis. So that's where y equals 0. So it's -1, 0. Okay. I don't know why they want you the x-intercept and not the y-intercept, but that's okay. That's that one. I'm going to change color for the next one. So here's my ruler. Don't worry about the skewing, that could be my fault. We draw in our little box and I count my rise. 1, 2, 3. It's also negative, right? So let's see if I think that it's actually going down 3. So my rise over run is -3 because it goes down. And 1, 2, 3, 4, 5, 6, 7, 8, 9. -3 over 9. I can divide both the top and the bottom by 1. So that will be -1 over 3. So my slope is -1 over 3. My x-intercept is right there. It's where y equals 0, or it's where it crosses the x-intercept. So that is 2, 0. Okay. Alrighty, let's look at the next one. I like the blue better. So again, I'm going to pick 2 points. I'm going to pick this point here and this point here. They look pretty good. They look like they're on the line. And I draw in my boxes. Again, you don't have to draw in the box. Looking at that, is it going to be positive or negative? Well, you can't answer me. But going from left to right, it's going down, so it's negative. So my rise over run, it goes down 1, 2, 3, 4, so -4. It goes over 1, 2, 3, 4, 5, 6, 7, 8. So that would be -1.5. I can divide the top and the bottom by 4. So -1.5. My x-intercept is right there. It's 1, 2, 3, 4, comma 0. And now my y-intercept is right here. Goes up. This is my x-axis, so it's 0, comma 2. Now that's pretty key, because now I have my slope and my y-intercept. So remember I said you can write it in the form y equals mx plus b. That will come up later, but just as a little teaser, you can write that as y is equal to -1/2 x plus 2, because of your slope and your y-intercept. Little teaser there for you. Okay, so let's look at this last one here. And my ruler. So I'm going to pick 2 points. I'm going to pick that point there and that point there. So we're going to draw in there. Oops. And here. And again, I just like drawing that triangle in because then it really clarifies for me what's going on in terms of that slope. So it's positive. From left to right, it's going up. So my rise over run is, well, it goes up 1, 2, 3, 4, 5, 6, 7, 8. And I'm counting the blocks in this case, okay? We're going to talk about how you can use points on the line in a moment. And the run, it goes over 2. 8 divided by 2 is 4, so my slope is 4. You could also write that as 4 over 1, but it's the same thing. Now here my x-intercept is right there, so that's -1, comma 0, and my y-intercept is up here, that's 0, comma 4. Again, I can write the equation of this line because I have the slope and y-intercept. Y is equal to 4x plus 4. Booyah! That'll come in handy later, okay? Now, sometimes we're not given that picture. We're just given 2 points on the line. So here, we can use, it's called the slope formula. It's very key, and it's using those 2 points. We just put it into this formula, okay? So we're going to do that. We are given 2 points here. I'm given this point here and this point there. And it says, the slope formula says y2 minus y1 equals x2, or over x2 minus x1. This is basically the rise over the run. We've just explained it though in terms of points. Okay, so this formula is just another way of writing rise over run. So if I have my points here, C and D, doesn't matter which one, I'm going to say that this is point 1 and this is point 2. And then I just substitute them in. So if this is point 2, D, my y2 is 1 minus my y1 is -3. Now notice I've got a minus and negative. I'll deal with that in a minute. My x2 is 2 minus my x1 is -5. Now, we have to remember our integer rules. So for this, we're going to go change a minus and negative to plus a positive, right? Now, 1 plus 3 is 4, and 2 plus 5 is 7. And that would be my slope. Now, it would work the same if I did it the other way around. If I made the opposite points, my points 1 and 2. So if I made this point 2 and this point 1, I'm still going to get the same slope, and I'll show you. So y2 minus y1 over x2 minus x1. If that's the case, then this would be my y2, -3 minus 1, and here I would have -5 minus 2. So I would get -4 over -7. Those two negatives will cancel out, and it'll be 4 over 7. So as you can see, doesn't matter which one we make, point 1 and point 2, we'll get the same answer. This formula is awesome. You don't have to draw your lines. You can just take those 2 points and substitute them in. Okay, now that's the lesson. There's a lot of examples there. What my encouragement to you is to maybe work through a few of them or look at the lesson. But hopefully this gives you a little foundation to help you out going into Monday.